Hello students. Today we are going to learn a topic called as projection over an inclined plane. Okay. So we learn a topic that is projection over an inclined plane. Generally NEET and JEE means these questions are very rare, but advanced they might ask these questions. So let me introduce to an inclined plane. In this inclined plane, how gravitation acceleration can be split into components. This is called as an inclined plane or a wedge. This angle is called as angle of inclination. Let us take it as theta. So when I take it as theta, any body, let us suppose if a body is something like this, the weight of the body acts downwards, which is mg. So the acceleration downwards is mg on this body. And this acceleration can be broken into two components. How can we break into two components? Let me draw a line like this. This is one component and this is another component. If this angle is theta, then this angle is 90 degrees and this angle would be 90 minus theta. Okay. So gravitation, this component would be g cos 90 minus theta and this component would be g sine 90 minus theta. Okay. So can I write g cos 90 minus theta can be written as g sine theta, and g sine 90 minus theta can be written as g cos theta. So we have got the components of acceleration are two. One is g sine theta along the incline and one is g cos theta, which is balancing the normal reaction. So let us now write the components. In this direction, we have g sine theta. In this direction, we have g cos theta. I hope you understood this. The acceleration due to gravity has been split into two components. Now, what we will do is, let us project a body from point A to point B. Let us take this body. It has been projected somewhat like this. Okay, from here to here. Now the questions will be asked. How the questions will be asked? First, let us understand how this is a projectile motion. That means I can break the velocity into two components. Let me write like this. Now, if the velocity in this direction and this angle is, let us assume alpha, this is u, the initial velocity would be u cos alpha and the vertical velocity would be u sine alpha. So what will happen? The velocity will be broken into two components as u cos alpha and u sine alpha, and this angle, let us assume it is theta. So theta. Now this gravitation is also broken into two components. The gravitation components I'm writing on this side. This way it would be g sine theta and downwards it is g cos theta. If you understood this much, then inclined plane, nothing is there in inclined plane. Everything is done. Okay. So this is what you have to understand. In normal projectile motion, the gravity was not broken into components. Only u sine alpha was being affected by gravitation. Okay. Whereas u cos theta or u cos alpha, whatever, the horizontal velocity is not affected by any acceleration. So it would remain constant everywhere. Whereas in this case, the u sine alpha is affected by g cos theta and u cos alpha is affected by g sine theta. I hope you understood this. Next, now let us write the equations for this. Okay, what are the equations that can be written? Let us write the equation in x-axis. So we have got three kinematic equation, that is v is equals to u plus at. Let us write this in x-axis. Velocity in x-axis is equals to initial velocity in x-axis is u cos alpha minus g sine theta into t. Why? Because if I take this axis as positive, the opposite one would be negative. So that would be g sine theta into t. The second equation, that is s is equals to ut plus half at square. This I can write as sx. That is displacement in x-axis is equals to u cos alpha into t minus half into g sine theta into t square. That's all. Yes. Next, the third equation, which is not required, v square minus u square is equals to 2jh. You can write it with this. Next, we'll see the y-axis now. Next, let us write the y-axis for equations for y-axis. So whenever we write equations for y-axis, the first equation is velocity in y-axis is equals to initial velocity in y-axis plus acceleration in y-axis into t. So velocity in y-axis is equals to initial velocity in y-axis is u sine alpha minus g cos theta into t. Yes. Next, displacement in y-axis is equals to uy into t plus half into ay into t square. What is u in initial velocity in y direction? U sine theta into t minus half into g cos theta into t square. That's all. Any doubt? Next we are going to see v square minus u square is equals to 2gh, that you can write. So now, if at all I want to find the maximum height, this point, maximum height. What is this height? This height, if I want to find out, the velocity, the vertical velocity will be 0 here. So can I write it as v square minus u square is equals to 2gh. V is 0. The final velocity in y-axis is 0 minus u square cos square, sorry, u square sine square alpha, because here we have to take vertical velocity. U square sine square alpha is equals to 2 into g cos theta into height. So height can be written as h is equals to minus u square sine square, here also g is negative, so u square sine square alpha by minus 2g cos theta. Minus minus gets cancelled. It is u square sine square alpha divided by 2 into g cos theta. That is the expression for maximum height. Then we can find the expression for time of ascent also. How much time it has taken to reach that point. Okay. We can use the first kinematic equation and we can write. So time taken to reach this point, time taken to reach this point. Let us take it as some C point from A to C, how much time it has taken. So time of ascent is equals to Vy is equals to Uy plus A into T, A in Y direction to T. Vy, the velocity there is 0. Yes, Y axis velocity is 0, is equals to Uy, that is U sine alpha minus g cos theta into t. If I send this g cos theta there, g cos theta t is equals to u sine alpha. T is equals to u sine alpha by g cos theta. This is my time of ascent. Anyhow, time of ascent would be equal to time of descent. So time of flight is equals to time of ascent plus time of descent, which is 2u sine alpha by g cos theta. Yep. Any doubt in this? So this is how we can write all the equations that are pertaining to an inclined plane, projection on an inclined plane. Next, let us write the final equation, that is range. So range, what is range? Range is nothing but the horizontal displacement. Horizontal displacement, we have already written the equation. Sx is equals to u cos alpha into t minus half into g sine theta into t square. This is what you have to use. Now range mean it is reaching from A to B or A to this point, some point D. That means time of flight has been taken. So range is equals to, in place of t, put time of flight. U cos alpha into whatever was the time of flight, 2u sine alpha divided by g cos theta. Okay, g cos theta. This is my time of flight. Yes. So minus half into g sine theta into the same place 2u sine alpha divided by g cos theta whole square. This will give you the range of the projectile. I hope you understood. Now let us do the projection if it will from the other side. Okay. Let us write the equations if the projectile motion is from the other side. If I projected something like this from here, if I'm projecting it something like this, then what will happen? Yes, the gravitation will have the same components. U is in this direction. U sine alpha will be in this direction. U cos alpha will be in this direction. And G sine theta will be in this direction. G cos theta will be in this direction. Yes. Now what will happen? Let us write the equations for x-axis and y-axis. So for x-axis, I'm writing the equations. What will happen in the x-axis? First one, velocity in x-axis is equals to initial velocity in x-axis plus acceleration in x-axis into t. So velocity in x-axis is equals to initial velocity in x-axis is u cos alpha plus g sine theta into t. Yes. If you want, you can take everything as negative. If you take everything as negative, because v is negative in this downward direction, u is negative, this is also negative, everything will get cancelled out. You are going to get finally as vx is equals to u cos alpha plus g sine theta into t. Why we have got same thing? This time, the u cos alpha and g sine theta are in same direction. So we are going to add up these two equations. Okay. Next will be displacement in x-axis. That would be u cos alpha into t plus half into g sine theta into t square. That's all. Then v square minus u square is equals to 2gh, same thing. Then let us write the equations in y-axis. Okay. Let us write the equations in y-axis. For y-axis, Vy is equals to u sine alpha minus g cos theta into u minus into t. Why? Why this has come? Because u sine alpha is still upwards, g cos theta is still downwards. So what happens? The body will be stopped in the midair. Okay. Then Sy is equals to u sine alpha into t minus half g cos theta into t square. This would be your displacement in y-axis. Okay. Next, v square minus u square is equals to 2gh. Now the maximum height, let us find out. So v square minus u square is equals to 2gh. V is 0 at that point. So minus u square sine square alpha is equals to minus 2g cos theta into h. Minus and minus gets cancelled. H is equals to u square sine square alpha by 2g into cos theta. The time of flight would also be same as it was thrown upwards. So time of flight would be 2u sine alpha divided by g cos theta. This would be your time of flight. It is just same as what we have done previously when the ball was projected from down to up. It's the same time of flight will be applied here also because the vertical velocity is being affected by gravity in the same way. I hope you understood this. Next, we will write the equation for range. Next, let us write the equation for range. What is range? Range is nothing but displacement in x-axis, which was equals to u cos alpha into t plus half into g sine theta into t square. This was my horizontal displacement. So in place of t, I have to put time of flight. U cos alpha into 2u sine alpha by g cos theta plus half into g sine theta into 2u sine alpha divided by g cos theta whole square. This is going to give you the range, that is the maximum. Now, what is the difference between the range of this and range of in the previous cases that we have done where we have projected the body from down to up? Now we are projecting the body from up to down. There it was u cos alpha 2u sine alpha by g cos theta. It would this sign was minus, so it was lesser. But now what happened? It is added up. So the range would be more when you project a body from top of an inclined plane towards down. The range would be less when you project a body from bottom of the inclined plane towards top. I hope this will answer all the questions that will be asked on inclined plane. Okay. Let us do this small question so that will give you confidence on this. So it says there is an inclined plane with a large base OB is along x-axis and it is being thrown from O towards P. Okay. So this angle is theta. This angle is theta has given is giving how much time has been taken. So time is nothing but time of flight, which is 2u sine alpha divided by g cos theta. That is 2 into the velocity is 10. Sine alpha is 1 by 2 upon g into cos theta is root 3 by 2, which is again 10. 2 ones to 5, 2 ones to 5, 5, 5. It is 2 by root 3 seconds. Okay. So this is how we have to do these questions, which are given on inclined plane. If you have any doubt, you can comment below. I'll be explaining you again. Thank you.